All right, this one is similar, but we are kind of looking at it from a different angle. Say we want to approximate the natural log of 1.06 to within an error less than 0.00001. So a couple things to mention. Everything in this section is going to be natural logs. Um, just to give you a heads up, there's not that many homework problems. Turns out natural logs are a really, really good thing to study when it comes to these approximations. And they would have been huge back in Taylor's day. So we're picking a different natural log within an error less than this. So let's say in this case, you know we don't need to get that number perfectly, but we also know we've got to get that accurate to within, what is this, 1, 2, 3, 4, 5 decimal places, 0.000001, for whatever our applications. Maybe, we're building something or designing something, and we want to use that number exactly, but we know we can just get very, 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 very close to it, and that's good enough. Okay, how are we going to do this? Well, again, we're going to use that Taylor series, that basic Taylor series of natural log 1 plus x. Okay. Here it is, same series we saw a moment ago. This time I've listed another term, so follow the pattern, right? X minus 1/2 x squared plus 1/3 x to the third. The next would be minus 1/4 x to the fourth. The next one after that would be plus 1/5 x to the fifth. Now the thing is, when we begin this problem, we have no idea how many terms we're going to need to get the error within that. So I just wrote it out to the fifth degree, 5 terms. It's possible, though, that we will need more terms than this as we go deeper into the problem. Okay, what are we going to do with that? Well, it's really just a matter of plugging in the value of x that we need. So if we're doing natural log of 1.06, then x equals 0.06. So I'm going to plug that in. And I just want you to look at this. So the natural log of 1.06 will equal 0.06. Okay, I'm just putting that in for x. I put the 0.06 in for this x, did the whole thing, and got that. So I recommend confirm that number in your calculator, 1/2 times 0.06 squared, and we're subtracting minus 0.0018. I put in 0.06 here, plus 0.000072. And then I got one more. Kind of what are we thinking as we're plugging numbers in, and how do we know when to stop? It turns out that was x. Turns out I knew to stop here at this fourth term. Okay, I should slide this back down. We know we want our error to be within this, 0.00001. First, look at these numbers. They're getting smaller every time. 0.06, 0.0018, 0.000072, 0.0000324 when you do the fourth term. Every time they're getting smaller. So that means as soon as our number drops below this number, we can stop. So x was that. Okay, well, that's not below this number. Plugging in here, well, that still not below this number. The third term, ooh, it's getting close. 0.00007. We have 0.00001. The next one does it. 0.0000324, and that is smaller than what our error needs to be. So here's what I'm noting. This is less than our error, so we can stop, go back to the others, ignore this number, just add these together, and that will get us the error to be within this guy. Since the next number is smaller, I don't need to include that number as well. since it's smaller than what I need my error to be. Hopefully that makes sense to you guys. So I'm just going to add these three, and I got it. The natural log of 0.016, I should really say, is approximately equal to, adding those, 0.058272 when I put those together. If I was to include the next number, it would only change the value. The value would change a smaller amount than what I am even concerned with. So where this is what the error is 00001, right? If I was to include this number, what it would, I think it would only affect numbers even beyond the 2, or maybe it would change this value here. So I'm good. I've got, it's not going to change it to beyond what I care my error to be. Okay, well, that's the answer here. There is a follow-up question, and you're going to see this in the homework, so I want to present it. Let me bring this back here. Hopefully, I don't know if I can fit it all on the screen. Maybe just that. What is the error to this approximation? Actually, I think I just went ahead and wrote it again. Being a bit clunky here. That's all right. What would be the error to our third degree Taylor polynomial? So this was, we said this was P3 of x. That was our approximation. That was our answer a moment ago. So the error is actually just the very next term. Why is that? Because if we were to include this term, our previous answer would only change by this much. And then future values are getting smaller and smaller and smaller. Also, the terms are switching between positive and negative. Positive, negative, positive, negative. So if I took that number I got just a moment ago and subtracted this, right, that's going to be the furthest away from the actual value possible, because when I go and add the next term, well, it's going to be added back on. So where I subtracted, it's like I drop down, then I add back. But when I add back, that number is even smaller than this. And so the furthest I'm going to deviate from the actual value is that very next term. So R3 of 0.06 is going to be less than that term right there, 0.0000324. All right, you guys, that's our last example. That is the entire course. You made it through all the lecture. Go check out the homework. See you in the live meeting.